When they say school is easy, they really mean it. Now we are doing trig, and let's just quickly go through it. It's not going to be too hard. So for trig graphs, I kind of recorded videos on a whiteboard, and you're going to see them below this, okay? For trig graphs, I'm going to kind of jump it. For trig graphs, you just have to know that you plot 90s, okay? You sketch 90s and whatever. So that stuff for trig graphs, you can see it in the video which I've put below. So for trig graphs, it's not going to be hard. Now here I want to talk about things that we should know. Number one, I want us to know the trig functions, okay? I want us to know the trig functions, everything you're going to need to know to answer the things we're going to put them now, okay? Then the thing is, we'll be now just answering questions and questions and questions. So let's do trig functions. I want you to know that, we know that there is sine x, we know that there is cos x, and we know that there is tan x. But then you should know the other ones. For example, you need to know sec x. And sec x is just 1 over cos x. Then you need to know, I know sec, you think it is going to be 1 over sine, but it's actually 1 over cos, okay? So sec x will be 1 over cos x, and then we have cosec x, which you'll be like, oh, cosec. In full, it's actually cosec, but we just write it as a CSC, which is cosec of x. This is, you'd say, oh, that's 1 over cos. No, don't follow your gut for these ones. Please remember, I say don't. It is 1 over sine x, okay? It's actually the opposite. Then we'll be now saying cot x will be now 1 over tan x. So we have these three. These must be known. These are just the trig functions. Then the second thing to know now, okay, is going to be the double angle formulas. So double angle formulae, okay, or double angle formulas. What are they? First one is sine 2x. You only need to know for sine and for cos. So sine 2x is going to be 2 sine x cos x, okay? This is the sine 2x. What is sine 2x? It is 2 sine x cos x, right? So it's like, what you'd be just knowing is double angles. You must know that it's not only for sine 2x, although you're going to get sine 2x a lot, but it can work also for if you had a sine 10x. This is just going to be 2 sine, you half this. If it's 10x, it'll be 2 sine 5x, then cos 5x. So if you see 2 sine 5x cos 5x, remember this will be a sine 10x. You double, then you know it comes from sine 10x if you see this. What about if I have a sine x? This will become 2 sine, you half it, is now x over 2, then cos x over 2. So if I ever see a 2 sine x over 2 cos x over 2, I know it's a sine x. Okay, it's gonna go. It comes from the double angle formula for sine. It's sine 2x is 2 sine x cos x. Then we have for cos 2x. Now cos 2x has 3 versions, so we must know all 3. Okay, it's going to be, the first one is, it's cos squared x minus sine squared x. This is going to be cos 2x. It's cos squared minus sine squared. Then we have cos 2x again being equal to 2 cos squared x minus 1. Then we have again the last one, cos 2x being 1 minus 2 sine squared x. Okay, so you should know that cos 2x is 2 cos squared x minus 1. Then 1 minus 2, you say it's a cos 2x, so it's going to be a cos x. From cos to cos, it will be positive, but from cos to sine, the sine will become negative. But remember, it is not just a sine x, it's a sine squared x coming from cos 2x. It's 1 minus 2 sine squared x. So here is the second one, which is for double. So what was the first? To know your trig functions, especially these new ones, what they mean. And you must also know that tan x, which we talked about already, is sine x over cos x. This should give you tan x, sine x over cos x. This should give you tan x. You should know that. Now, are we done? No, we are not yet done. We'll go to the third thing now that you should know. And the third thing we can just say is going to be now compound angle formulas, okay? The compound angles. So it's like addition and subtraction, whatever. So these are some compound angle formulas. What do we have? We have, you should know how you expand sine of 2 things adding, a plus b. You should know how to expand sine of 2 things subtracting. You should know how to expand cos of 2 things adding. You should know how to expand cos of 2 things subtracting. You should know how to expand tan of two things adding, you should know how to expand as well. Tan of two things subtracting. These ones must be known by heart. Really? Yes, you must. What are they? What is sine of a plus b and sine of... Okay, so here you should kind of remember something about them that will help you remember. We always start with the cos one. It's very easy. What is cos of a plus b? Now, when you're expanding a cos and there are two things adding inside a bracket, we don't care if they are adding or subtracting. If you are expanding a cos, you must know that when you expand a coses start, then sines will follow. So how cos does is he's going to bring two coses, then he's going to bring two sines. We don't care whether there is addition or subtraction. So cos a plus b is going to be cos a cos b. The coses start. Then after that, the sines will now come. Sine a, sine b. We'll put the sign in between, don't worry. Then again here, it's a cos, right? So if it's a cos, please just go ahead and do cos a cos b, then do sine a sine b. So the two coses will come, then the two sines will come. Now again, another thing which he does, if this is a plus, it will be a minus here. If this is a minus, it will be a plus. So for cos, he changes the sign. Okay, he brings the coses, then he brings the sign. Then in between them, he changes the sign. Now what I want you to see is, although this was an a minus b, when we were putting it here, we put it as a b, not as a minus b. This minus is only important when we are now putting this sign, okay? But for the others, you ignore it. Now let's do for sine a plus b. What is sine a plus b? Now for sine is, he interchanges. It will be sine and cos, then sine. So it's going to be, but sine starts in the first one. So it's going to be sine a, then cos b. So sine starts. Then cos will now start. Cos a, sine b. So they come together, but in the first one, sine is the one that starts. So he takes the first thing, okay? That's the same we do in the next. So it's going to be sine a cos b. Then we're going to say cos a sine b. Now, what is the other thing we see? If this is a plus, you put a plus. If this is a minus, you put a minus. So that is the other thing you must also know. Then now let's go to the tan. So for sine, he does not change the sign. If this was a plus, you put a plus. If this is a minus, you put a minus. Remember that if it's a minus b, when you are still putting the angle, you just take the b. This minus is going to be the one which determines this sign only, right? Wow. You're on your way. This is amazing. I'm loving the work you're doing. This is how we're going to do. And you're going to see how natural solutions will come if you know these things, okay? Solutions will come on their own. Don't worry about the solutions. They'll come on their own. Just make sure you are very, very good with this. You have to be. You should know what the trigs mean. You should know the three double angles by heart. You should know these expansions. You should know what is tan a plus b. Now for tan, you expand like you do in algebra first, okay? So it's like you say tan times a, this goes tan a, then plus tan times b becomes tan b. But you don't finish there. You now say O over. If this was a plus, you now say 1 minus, okay? You say 1, and if this was a plus, you now say minus, then you put tan A, tan B. Let's do for this one now. What is the first thing we do? We expand, right? Tan times A, tan A. Tan times negative b is minus tan B. Then we say O over 1. Then if this was a minus, you now say plus. Then you say tan A, tan B. How good is this? This is it for tan, and you would be done. Now we go to the last bit. Wow, this has been fantastic. This has been fantastic. Now let's do the last two things. Still here. We're still doing these. We are now doing the third thing. What is the third thing that you must know? You must know the exact values. You must know what are exact values, okay? And when we say exact values, these will be exact values for special angles, okay? You'll be having special angles that you must know what their exact values are. Let's put these exact values for special angles. What are the special angles? They are 30, 45, 60, 90, 180, 360. These are the special angles, okay? These are your special angles. Now, what are they in rad? Because we will be meeting things in rad usually, not even in degrees. It's pi over 6, then pi over 4, then pi over 3, then pi over 2, then pi, then 2 pi. These are special angles. You must know them. These ones you must know, okay? You must know them, especially their radian forms, okay? Now, you are going to be expected to know the exact values of these things, and you're going to see where they say find the exact value. I'll show you where it comes from. So these special angles, what must you know? You must know the values which they give you. You must know the values which they give you. What are the values which they give me? Well, we start with for cos x and for sine x. For sine x, when you punch them, either you're going to get a 1 or you're going to get a 0. So either you get a 0 or a 1, or 0 or a half, or a 1, or a root 2 over 2, or a root 3 over 2. Now, I want you to know that this root 2 over 2, if it's a calculation, we write it as 1 over root 2. It's the same thing, okay? So the possible solutions are 0, half, 1, root 2 over 2, and root 3 over 2. Now, you should know if you're doing a calculation, root 2 over 2, you're going to write it as a 1 over root 2, because in a calculation, it makes your job easier. But these are the potential solutions. You say to me, why are you even telling me that? What does it have with me knowing the exact value? Because for you, for exact value, they'll say, please tell us what is the exact value of cos pi over 4. What is the exact value of that? Now, you are going to punch it in the calculator. Let me punch it in mine. Calculator is in red already. I'm going to say cos, open bracket, pi over 4. So I'm going to say cos, open bracket, then I say pi over 4, close bracket. Okay? I put my pi over 4, sorry for that. Pi over 4. All right. Then I close. This is going to be equal to, I got, this one is giving me 0.7071. Now, you must know that they don't want that. What did we say? We said the solution is going to be one of these ones. So you are getting 0.7071. Is it 0? No. Is it half? No. Is it 1? No. Is it root 2 over 2? Maybe. Is it root 3 over 2? Maybe. But you must see which one is it between these two. So the root 2 over 2 is the 0.7071. Then this would be 0.86 blah, blah, blah. So if you get 0.707, you are just going to write root 2 over 2. Okay? Now, what if you didn't know that 0.7071 is a root 2 over 2? Your calculator will never give you that. That is why we are giving you this list. If you get 0.7071, remember, it is the root 2 over 2. There is no way you're going to punch cos of these angles and get an answer which is not on this list. Your answer is going to be one of these ones here. So you should just choose which one, and this is the form which you want. If you get 0.5, you are going to choose half. If you get 0, of course, you choose 0. If you get 1, you choose 1. If you get 0.86, you are going to write root 3 over 2 as your solution. If it was a calculation, you get 0.70, it's going to be 1 over root 2. Now, what about for tan x? What are the values that tan x can give? Can it give 0, half, root 2 over 2? No, it doesn't give root 2 over 2. So what does it give you? It will give you 0, 1, then it will give you root 3, then it will give you 1 over root 3. These are the possible values for tan x. And the other one will be just error. Error, you don't leave it. Error just means infinity, so don't worry about it. We don't care about that one. We'll be wanting for the special angles. Now, this root 3, if you would get it as a solution, the solution you would see written there is going to be 1.73. So the bigger one, 1.73, right? 1.73, blah, blah, blah. If it's just 1 comma something, just know you put root 3. Then the 1 over root 3 is the one which will be 0.5 something something, okay? Then you know it's the 1 over root 3. That's the one you are going to put as your solution. So you would have punched tan of pi over 4, tan of pi over 3, of whatever. Then you get 0.55, whatever. You put 1 over root 3, please. That is the solution to put. I hope you understand something, or you have heard something, which we'll come back to, of course, finally when we are now doing the questions. But I need you to have all this for the time when we will do the trig questions. So this is so important. These are the exact values. Now, what is the last and final thing, which is going to be for part 4? I should then just give you the identity, which says, you must remember this identity, which says that sine squared x plus cos squared x is equal to 1. You must remember this identity. Now, what I want you to know is, you see this identity, we write it like this, although you will never be tested on it this way. Actually, when it's being tested, you'll be having to replace either sine squared or cos squared. So what happens if, let's say, I take cos squared to the other side? What will I remain with? I'll remain with sine squared x being equal to, on the other side there was 1. Cos squared is now coming. He was adding on the left. When it comes to the right, he will subtract. So it'll be 1 minus cos squared. So we can see that sine squared is 1 minus cos squared. What if I now take sine squared to the other side. Take him to the other side. I will now remain with cos squared x being equal to what was on the other side. 1 was already there. Then sine squared goes, it will subtract. So it will be 1 minus sine squared. These are the versions which I will use. Sine squared is 1 minus cos squared, and cos squared is 1 minus sine squared. Where do they come from? They come from this identity, which says sine squared plus cos squared is equal to 1, but it's not the version which we will use. I hope you remember that. Don't ever forget it. Now, if you master this one for trig, for hyperbolic trig, it's not going to be hard. These are the things we need to do what? To do exact values. And to do what? And to solve identities and exact values. We are going to need, not for hyperbolic, but for trig themselves, we are going to need what we have done so far. Okay? If you know this whole thing which you have done, then it's going to be a walk in the park and it will solve itself. Now we go to hyperbolic trig. Then we are going to go to continuity and differentiation. So let's go to hyperbolic trig and let's see. But first, make sure you're a master of this. Goodbye for now. See you in the next one.